Okay, students, now we have a new example that has like kind of new idea or technique that we will see, okay? So first we have this one and this one given, and we want to find this one. And as you've probably noticed, we have different numbers here, 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 and here. So how can we solve this, okay? Now first let's uh, let's see if we have something like sigma r equals 0, 9, okay, fr, and let's say we have another sigma of r equals, like, let's say 3, 5 fr, okay. Now what is this equal to? This is equal to f0 plus f1 plus blah 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 plus f5. Okay, now what is this one equal to? This one equals to f3 plus f4 plus f5, right? And if you notice, this one equals sigma of r equals to 5 plus f of 0 plus f of 1. So as you can see, we can kind of manipulate the sigmas even if we have different r's, like r value, or different n value here, okay? Now let's see how we would solve this question. Now mind you, this is not a general separate rule. This is just like kind of something that you would notice like even in the exam, like with no rules. This is kind of intuitive, okay? Now let's start solving. And one thing I forgot to mention is that when we have r equals k and c, k, c, and are all constants, okay? This is equal to c times n minus k plus 1, okay? This is the general rule of the one that we discussed here. This is the general rule of this one, okay? Okay, let's continue solving. Okay, first we have the sigma of r2, 9, 2 of r plus 3. Of course, first I will distribute the sigma here and here. So we will be left with simply sigma 2 of r plus sigma 3. Now this sigma 2 of r is basically 2 times sigma of r, and sigma 3 is basically 3 times n minus k plus 1, and n here and k here is 2, n is 9 plus 1, so it's 2 times sigma r equals to 9 fr plus 3 times 8, which is 24, equals 72. So we will just kind of isolate this one, this sigma, and see like what's the next step in solving, you know? So we're just like kind of investigating the given, and just like kind of like um, if you want reshaping it to see if we can get anything beneficial from it. Now let's isolate sigma of r. 9 equals 72 minus 24. So it's basically 72 minus 24 on the calculator gives us, of course, over 2, 24. Okay. We know, okay, let's put this as in like kind of star here, okay? We know that sigma r29 of fr equals 24, okay? This is the first given that we concluded. Okay, let's see the second one. This one. Okay, let's see what we can extract from it. And it's pretty much given straightforward. We have FR, okay? I'm just gonna put this as a conclusion, okay, here. Okay. We have both these informations, okay? How can we possibly get into the answer? How can we reach the answer? Just wait 1 second. Okay. The question is to evaluate this one. Now, what is this one? Like, I mean, it looks hard and stuff, but let's see how we can genuinely solve it, okay? First, let's expand it. Sigma r equals to 5, 3 times fr minus 4. So it's sigma 3 times fr minus sigma 4. This 3 will go here. It's sigma fr minus sigma 4. And sigma 4, we know it's n minus k plus 1 times 4, which is basically 5 minus 2 plus 1, which is 5 minus 1, which is 4 times 4, which is 16. Minus 16. We have to evaluate this one. Okay, now first let's see. 3 times the sigma of fr, not 2, 9, but 2 r equals to 5 plus or minus 16. Now, the whole question is about this one, is about this term. How would we evaluate this mysterious term? And the question is that if you notice here, we have different terms here. We have 2, and here we have 6. And so let's like kind of try to arrange them, okay? We have, what we want is this one. Okay, let's write it formally. So it's basically f2 plus f3 plus f4 plus f5, right? We want this one. But what we have is this one and this one. Let's also write them formally. Okay. We have f2 plus f3 plus f4 plus f5 plus blah 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 plus f9 equals 24. Okay. And for the second one, we have f of 6 plus f of 7 plus a blah 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 plus f of 9. Oh, I think you've noticed something here. Equals 8. Now look, we have common terms between both of these equations. We have from f of 6 till f of 9. Okay? F of 6 till f of 9. These are common terms, okay? Let's name them k. So we have f2 plus f3 plus f4 plus f5 plus k equals 24. And you also know that k equals 8. Oh, so what do we conclude? We can basically conclude that plus 8. We can get this here, so it's equal to 16. Boom. This is, if you can see, there's a really dangerous plot twist here. This term that we want is the same as this term that we got. So basically the question is easily solved like this. So since we want 3 times this sigma, which is equal to this one, which is equal in turn to this one, so we just put 3 times 16 minus 16, which is basically 2 times 16, which is 32. And this is how we've solved this question. Okay, so basically this was the rule that we used in our question, okay? This is kind of like, you know, it's, look, if we have RK here and we have M here, and followed by a sigma where R is the term that's after m ending in n, so we can simply just say that it's r equals kn. So if we have something like this, it's like some kind of like recurring one, we can just eliminate this and eliminate this, and we will be left with r equals k and n in the sigma. Okay, of course, and of course we have to have the same fr, like the same function. You can't have like gr, you can't have like hr. Like if fr was 2 to the power of r, we cannot say that we can apply this to sigma of r and another sigma of gr. Okay, this is like impossible. This is like irrelevant. So this was the main rule that was used, and thank you.